Hello friends, in our last lesson we learned about Euclid's lemma. Aman and Khushi got 63 and 49 questions respectively as their summer homework in math. They did same number of questions every day to complete. Remember, same number of questions. Can we tell how many number of questions they might have solved every day? As they are solving same number of questions, we need to find the highest common factor of the total number of questions given to them. That is 63 to Aman and 49 to Khushi. This highest common factor or HCF will give what is the number of questions each of them did every day. How do we do this? We learned in our previous video about Euclid's division lemma. Let's put 63 and 49, which are the questions given in Euclid's division lemma. So let's do 63 divided by 49. So what we'll get? We'll get 63 is equal to 49 into 1 plus 14. That is, if we divide 63 by 49, on your copy you will get 1 as the quotient and 14 as the remainder. Now, in the next step, we take divisor 49 and the remainder 14. We will again put them in the Euclid's division lemma. Now 49 becomes the dividend and 14 becomes the divisor. So we'll do 49 divided by 14. We will get 49 is equal to 14 into 3 plus 7. That is 49 divided by 14 gives 3 as the quotient and 7 as the remainder. So now we take 14 and 7. We again put them into Euclid's division lemma. This time we will do 14 divided by 7. So we will get 14 is equal to 7 into 2 plus 0. So now the remainder has become 0. We cannot proceed anymore. So the divisor in this final step, that is 7, is the HCF of 49 and 63. This means Aman and Khushi are doing 7 questions a day as their homework. So this is how the Euclid's algorithm works. Say we want to obtain the HCF of C and D, where C is greater than D. First step is to apply Euclid's division lemma on C and D, that is, do C divided by D. So we will find the unique numbers Q and R such that C is equal to DQ plus R, where Q is the quotient and R is the remainder. Now, if R is equal to 0, then we stop here. The divisor D itself is the HCF of C and D. But if R is not equal to 0, we apply the division lemma using D and R. In the first step we used C and D, C divided by D. Now we will do D divided by R. And we keep repeating this until the remainder is 0. And the divisor of the final step will be the required HCF. Let us take another problem. Manilal is a sweet shop owner. He has 135 burfis and 330 laddus in his shop. He wants to stack them separately in trays such that each tray has same number of sweets. This means no tray will have both the sweets. The number of sweets in each tray will be same. Many sweet shops do that in real, because this way they can have all the trays of the same size. It is easier to purchase and store. And by not mixing two different sweets in the same tray, it looks beautiful too. So now we take 330 and 135 and we try to find the HCF of 330 and 135. That HCF will give us the number of sweets in a tray such that each tray has the same number of sweets. So we put them into Euclid's division lemma. That is, A is equal to BQ plus R. Use the larger number 330 as A and smaller number 135 as B. Divide 330 by 135. We can find 330 is equal to 135 into 2 plus 60. That is, quotient will be 2 and 60 will be the remainder. The remainder is not 0. So we will take divisor 135 and remainder 60 for the next step. We again put them into Euclid's division lemma. 135 divided by 60. We can represent now 135 is equal to 60 into 2 plus 15. The remainder 15 is still not 0. So we take 60 and 15 for the next step. We put them into Euclid's division lemma. 60 divided by 15. We'll get 60 is equal to 15 into 4 plus 0. Now the remainder has become 0. This means the process stops here. This means the divisor at this stage, that is 15, is the HCF of 330 and 135. This means Manilal should arrange in such a way that each tray will have 15 sweets. That's all for now. Bye-bye.